Good morning, students. Your teacher here, Mr. Sarasinski, with another episode of Algebra 1, Lesson 8.15, linear versus quadratic models. And you guys have already had some experience with linear models, linear regression, line of best fit. This was last semester, but we used our calculator to calculate the line of best fit. And we're going to be doing the same thing today. So hopefully as we get into some of these examples, your memory will get triggered. But anyway, we're going to be graphing some functions and then deciding whether they're linear or quadratic, which should be very clear, and then calculating the line of best fit or the linear regression model based on those points. So let's get started. Linear equations should be in the form, y equals mx plus b. This is slope-intercept form. Okay. And quadratic equations should be in standard form, which is y equals ax squared plus bx plus c. And hopefully either one of those equations is not a surprise to you. All right, so in the following examples, we're going to use a graph. So we're going to plot these points in the table that are already made for us. And we're going to use the graph to determine if the model is linear or quadratic. And then we're going to use our calculators to write an equation to represent the data. So let's get started just by plotting these points. And as always, when you're plotting points on a graph, start at the origin, go left 2, down 7. And I always like to know how many squares are in each section. So I know that there's 10. So I can go left 2 and then 3 from the bottom. I don't know about you, but sometimes when I'm looking at these grids, it can get kind of mystifying. Like I get lost trying to look at all the squares. All right. So negative 2, 7, 0, negative 3, so just down 3. 1, negative 1, right 1, down 1. 3, 3, right 3, up 3. And 5, 7, right 5, up 7. Okay, then I connect the dots. So linear, quadratic, hopefully clearly this is linear. And I'm going to take those points now, and I'm going to teach you the steps. So the first button you're going to hit on your calculator is stat. It's right next to the variable key, and it's also kind of next to the left arrow. So you hit stat. First choice is going to be edit. And it's actually the first thing that pops up. So you don't have to go anywhere. Just click edit. And then you should see your L1 and L2. All right, so when you see your columns, you should see an L1 and an L2 column. And you're going to put your X values in the L1 and your Y values in the L2. And so take a minute to go ahead and do that. All right, once you've put all the values into your calculator, then you're going to hit the stat button again. And you're going to go right 1 over to calculate where it says calculate at the top. And for this example, you're going to choose number 4, linear regression. Okay. So I'm going to do this. Oh. And if you choose linear regression, you may have to go down to calculate. I don't know what your guys' calculator does, but it should give you y equals ax plus b. And then it tells you the values for a and b. And in this equation, it's y equals 2x minus 3. Okay, Next example, let's go ahead and put our points on the graph. -3, 2, left 3, up 2. -2, -1, left 2, down 1. -1, -2, left 1, down 2. 0, -1, 1, 2. Okay, connect the dots. That line is too wonky. I just can't accept that. Okay, so this sure does look like a parabola. So this is a quadratic graph. And now I'm gonna go ahead and put these points into my L1 and L2. And just for time purposes, I want you guys to know that you can just type right over the old points. You don't have to erase them first. So go ahead and put those, go back, stat, edit, and then put all the X values in your L1, all the Y values in your L2. And then this time, we are going to be choosing number 5, which is quadratic regression. Okay, so go ahead and put those points in your calculator. And if you put those points in your calculator, go back to stat, go over 1 to calculate, and then choose number 5. You should get y equals a is 1, so 1x squared, and you don't have to put the 1, you can just put x squared, plus 2x minus 1. All right, number 3. Let's go ahead and plot our points. 1, -5, right 1, down 5. 2, -2, right 2, down 2. 3, -1, right 3, down 1. 4, -2, right 4, down 2. And 5, -5, right 5, down 5. Looks something like that. Okay. So this looks like a good old-fashioned parabola opening upside down. So this is quadratic. It has been reflected over the x-axis. And we need to calculate our equation. So put these x values in your L1, y values in your L2, and then go back to stat, calculate quadratic regression. And if you run your quadratic regression on those points, you should get the equation y equals -1x squared, or just -x squared, plus 6x minus 10. All right. Number 4, -4, 7, left 4, 1, 2, 3, 4, up 7. Okay, -2, 6, left 2, up 6. 0, 5, up 5. 2, 4. And 4, 3. All right, so I went ahead and plotted that last point. Let's go ahead and connect the dots. And this looks like a linear equation. Go ahead and put those points in your L1 and L2 and calculate your linear regression. All right, so if you put those into your L1 and L2 and you ran your linear regression, okay, you should have gotten y equals -1/2 x, or your calculator probably gave you y equals -0.5x plus 5. Okay. Either one of those will work. All right, let's go to the next page. Number 5 and 6. Go ahead and plot your points. So left 2, down 2. Left 1, up 1. Up 4. Right 1, up 7. and write 2 up 10. All right, connect the dots. And this clearly is linear. Okay, so this is your L1, this is your L2. Put those in and then run your linear regression. And if you ran your linear regression with these points, you should get y equals 3x plus 4. All right, next example. Number 6, negative 4, 11. Well, that's going to take me off the graph, so I'm not going to plot that one. Negative 2, 6. Left 2, up 6. 1, 2, 3, 4, 5, 6. 0, 1. 2, negative 4. Right 2, down 1, 2, 3, 4. And 4, negative 9. Right 4, down 9. Okay, connect the dots. Okay, put these in your L1 and L2. Now, even though we didn't plot negative 4, negative 11, or negative 4, positive 11, you're still going to put that into your L1 and your L2. Okay, so this is linear. Okay, run your linear regression. And if you ran your linear regression, you should have gotten y equals negative 2.5x plus 1. And as fraction, that would be y equals negative 5 half x plus 1. I personally like my slope to be in fraction form because it's rise over run, so it tells you exactly what to do. If it's in decimal form, it's a little more complicated to think about, I think. Maybe not. All right, number 7. Let's go ahead and plot our points. Okay, so 0, 1, up 1, right 1, down 4, right 2, down 5, right 3, down 2, and then right 4, up 5. Well, this is definitely not linear. Okay, this is a quadratic and a little lopsided, but that's okay. So this time, we're going to put these into our L1 and L2, and this time we're going to run quadratic regression. Okay, so go ahead and put that in your calculator and run your quadratic regression to get the equation. And once you run your quadratic regression, you should get y equals 2x squared minus 7x plus 1. All right, last example like this. Let's go ahead and plot our points. Negative 8, negative 3, negative 6, positive 5, negative 4, 9, negative 2, 9, and 0, 5. All right, so this looks like a quadratic. It looks like one where we don't have the vertex, right? Turns around somewhere in there, but we're not really sure where. So since they're not linear, it's quadratic. And we're going to put these points in our L1 and L2, and then go to calculate quadratic regression. If you ran your quadratic regression, you should have gotten y equals negative 0.5x squared minus 3x plus 5. All right, last two examples. So now we're going to take those lines that we've been calculating, our linear regressions and our quadratic regressions, and we are going to use them to make a prediction. Okay, so it says the value V of a computer between 1999 and 2003 is given in the table below. Write an equation for the line of best fit, then predict the value of the computer in 2008. And since it said it was the line of best fit, okay, not the curve of best fit, I know that this is going to be linear regression. Okay, no, it's going to be linear regression. So that's nice. However, we still have some work to do. So anytime you're putting years into your calculator, always make the first year 0. That makes every year after that much smaller numbers to deal with. Okay, that's just why I like to do this. I think it's just easier to think about for me. And time is going to be my L1, and then value is going to be my L2. So I'm going to go ahead and put these into my calculator, stat, edit, and then you can just type over your L1 and L2, 0, 1, 2, 3, 4. And my L2, 800, 720, 640, 572, and 480. Stat, calculate, linear regression. And I got y equals negative 78.8x plus 800. Okay. It says predict the value of the computer in 2008. Well, 2008 minus 1999 is 9 years. So 9 is the value that we're going to substitute in for x. Y equals negative 78.8 times 9 plus 800. Okay, negative 78.8 times 9 plus 800 equals 90.8. So the value of a computer is steadily going down, which is nice because let me tell you, they used to be really expensive. Whenever I was in college and I bought my first laptop, it cost me $1,200. As compared to now, I can get one with like the highest processor for less than $1,000. And you can get good laptops for $500. So anyway, all right, let's keep going. Number 10, a coin is thrown off the top of the Statue of Liberty, which is 305 feet from the ground. The height h of the coin is recorded after each second in the table below. Write an equation for the curve of best fit, then predict the height of the coin after 7 seconds. Okay, so this is my L1, this is my L2, and this time we're running quadratic regression. Okay. And nothing fancy here, just put those values in just like they're given to you. L1 is going to be 0, 1, 2, 3, 4. Oh, look, we already have those in there. L2 is going to be 305, 367, 397, 395, and 361. Stat, calculate, quadratic regression. And you should get the equation y equals negative 16x squared plus 78x plus 305. Okay. Now it says predict the height of the coin after 7 seconds. So 7 is going to become my x value. So y equals negative 16 times 7 squared plus 78 times 7 plus 305. And you can put this right into your calculator, just like I've written it there. Negative 16 parentheses 7 squared plus 78 parentheses 7 plus 305. And you should get the height as 67 feet. I'm your teacher. This has been linear versus quadratic regressions. This is the way.